Morning, everybody. I'm surprised to see so many people on Saturday morning. Thank you for coming. I hope I can justify your trust. First time I've done a 90-minute talk, so a bit nervous. Bear with me. I will be reading my notes. I haven't memorised this. So, right, how to delete code. Press the delete key, or select something and press the delete key, obviously. But if it's that easy, why is there so much dead code out there in the world? So hopefully in this talk I'll explain how we get dead code and then go on to see how we can prevent it appearing in the first place, and if it exists, how we can delete it. So a bit of scene setting so I can get over my nerves and you can all settle down. This is me, I'm Matt, BBC Micros. That's where I started a long time ago. I see dead code. Some people don't. This has become apparent to me, hence the talk. I can't help it. There we go. I haven't got an agenda for this talk. I'm simply talking from personal experience. I'm not a tool vendor. It's not a marketing talk. It's just a load of war stories, really. So the first 15 years of my career was mostly spent writing new code, various companies, new products. So there was no dead code, or I was too inexperienced to see it or care about it. The next 15 years or so, especially as a contractor, I've seen a lot more code bases and a lot older code bases, so I've become more aware of dead code, and it's become a thing for me. And as my grey cells fade, I don't want to waste what brain power I've got left reasoning about dead code that shouldn't be there. I just want to see what I do need to see so I can get on with my job. Yeah, that's enough on that. Right, what I do now is write C++ at a small company called RF Pro. We do a driving simulator that started out about 20 years ago as a game called Race Factor and is now Race Factor 2. So it's, as I said, it's at least 20 years old. It was originally written in C. It's now sort of C++ with classes. Sorry, C with classes. But it is well engineered by a small, it's like all games. It was written by a small team. It's extremely well engineered. When initially it was, the architecture was tight and consistent. It made a lot of sense. It was 100% fit for purpose. It's a popular game. It's still going 20 years later. It was very successful, and there are parts of it that haven't been touched 5 or 10 years. You know, code that is completely 100% fit for purpose, and it just sits there and does its job. So our company took this game and started bolting on DLLs to extend the functionality kind of out of the side. For professional use, for CAD and motor manufacturers, motorsport teams to modify the simulation to their purposes. So it's still moving. The code base is still moving forward. We're adding new features all the time. You can't really see the bottom right slide, but that's ray traced. It's not real time, but we ray trace images for cameras and stuff for AI autonomous vehicle sensors. Yeah, it's very interesting, but challenging because it's an old code base, and being a game, there's a lot of dormant game features in there that we just don't need. So target audience is, hopefully, I don't see anybody here that looks like they're less experienced. But anyway, hopefully people watching the videos will learn from our mistakes and not fall into the traps in the first place. The more experienced, I'll hopefully remind you that there is a better way. And if you feel trapped, with a messy code base, maybe I'll help you get out of it. And if you don't fit any of those categories, I won't be offended if you now leave. It's a hand-wavy talk. It's not particularly technical. There's hardly any code. Hopefully it'll apply to all languages. It's a C++. The examples are in C++, but you know, that's just because I write C++. It's a very personal view. Your mileage will vary. If you've got questions, pipe up. There is a Q&A at the end if we have time, but feel free to interrupt. Your different mileages will be interesting to hear about. Yeah. The agenda is that I've broken it up into questions, so I'll be going through it in that order. To start with, the whys are trying to understand why we get dead code. If we can understand why we get it, we can maybe prevent it appearing in the first place. But then given that we've got it, what can we do about it? So some thoughts about the kind of environment your code might exist in. I think that if anybody still is working in sort of big upfront design, waterfall type projects, if the big upfront design is complete enough, then when you come to write the code, there won't be any dead code because it's all specified and you'll just fill in the spec and the job's done. And because the waterfall progresses linearly through time, the traditional waterfall, there is no go back steps. So there's no point at which you can go back and review the code you've written and go, oh, maybe we need to massage that or refactor it or fix it, because the spec's perfect. You're just a monkey, you code the spec, job done. The opposite of that really is agile, where it's all about iteration and going back and sort of modifying the code as you go. So I suspect that the kind of stuff I'm going to be talking about today is a good fit for agile and a bad fit for big upfront design. But you can draw your own conclusions. In new projects, there should be little scope for dead code, as I found in the first half of my career. Maybe I just didn't notice it. It's still possible, but it's just less likely. Old projects is where it really lives. It's rife, so legacy code. And in libraries, you have the problem of not really knowing what you're going to need. So there's a tendency to sort of add everything, and then some of that will immediately be dead code. You just don't know. So it's a bit tricky with libraries, I think. Whereas with an application, it's well defined, so you know what you need, and you should be able to reason about what you don't need if you see it. Right, a disclaimer. We should never think about old code and deleting it and finding out why it's there with a sense of blame. You should never blame anybody. They just wrote the code, they're just doing their job. It's absolutely not personal. So if anyone can detect that I'm talking about them, it's just an example. And if you're doing this at your job, just accept the fact that it's somebody wrote it, but it's not. You're not talking about them. It's not their fault. You're just talking about the code. Because they had no choice. We've all been there. You're usually told what to do. You just do it. To the best of your ability, but often under pressure. So the code is what it is, and you take it as you find it. In the commercial world, you always have to remember that by some definition, it's fit for purpose because people are paying for it. So even if it looks appalling to you, it's still making money. So, that's the bottom line. You might want to improve it, but there is an argument for just getting on with the job. And particularly with older projects, you are standing on the shoulders of giants. That's our game that we work on. The original team was absolutely excellent, and there are usually glimmers of that in an old code base. So the idea is to learn from the situation, not necessarily the mistakes, but learn from the current situation, and maybe learn about ourselves as well and what we're doing and how we're doing it. And improve things. That's the main goal, is to improve the code base, improve your practices. Right. So why should we delete code? And why is it there? And why hasn't somebody else deleted it already? So what's that? It looks like some trees. But it isn't. It's a load of animals. It's confusing. Hopefully it took you a lot of mental effort to look at that first picture. You're going, what can I see? Am I hungover? Do my glasses need a new prescription? Is the projector working, etc.? You can't look at that in a blink and go, that's some trees. If it was two pictures of some trees and some animals, it'd be really easy to understand. There's an exaggeration, but hopefully illustrates the point. If this was code, messy code is hard to comprehend. And imagine if every file or every module in your code base was like that, and sometimes it is. So we're trying to avoid that situation, really. So there's a phrase for that, which is cognitive load. So when you're reading a code base, it can be confusing. You can then get distracted by the mess and the confusion. It's like, what's this? I need to go and read about it to understand it. And oh, actually, that was irrelevant. So it just distracts you. And it can mislead you in other ways, like how big is the code base? If it's full of mess like that, you just do a line count on it. Oh, we're working on 100,000 lines of code. No, it's 50,000 and 50,000 lines of rubbish. It's just confusing. Dead code can be a security risk. I'm not a security person, so this is just sort of off the cuff, really. There's an implicit risk that if you've got a lot of dead code, how much care are you taking about your code base? So what other mistakes are there in there? It's kind of just sort of sums up the attitude of the company or the project in one way. Yes. Yeah, and we've had examples of that compiler trick earlier in one of the keynotes, yeah. Properly unreachable code isn't really a security risk, because if it's provably unreachable, you can't execute it. But dead code might not be tested, and forgotten features that are kind of dormant rather than dead are genuinely risky. So yeah, dead code wastes resources, memory, disk space, the kind of stuff that people don't care about anymore. But imagine if Windows was 10% dead code, how many copies of Windows are out there in the world? How many tons of memory chips, how many power stations to keep that lot going? It's worth thinking about. And it wastes time, and time is money usually. The cost of removing the dead code is far more obvious, because it's clear that you're doing it, but there's a hidden cost of carrying all that dead code around from day to day that people don't notice. And I suspect that for a long project, that might be the more significant cost. So yeah, dead code affects the efficiency, not of the running program because it's not running, it's not taking up CPU cycles, but it is stopping the project team being efficient. And that, again, that's time and money. So why do we have dead code? So in old projects that are old enough for the team to change, or the company culture to change, or the requirements to change, or the technology to change, it can be old enough for the architectural vision to be lost, or the sort of the original kind of team spirit to be diffused. And we can lose knowledge, basically. And lost knowledge in the development team can lead to these kind of problems. So if you don't really know what you're doing, because where am I going with this? Excuse me. Yeah, if the original design decisions have faded and no one knows why the code is as it is, you don't necessarily know why something is that way. So when you come to work in that area of code, you have to be tentative. So you're not confident about your changes. So you tend to go for the smallest possible change, the least disruptive change, rather than the correct change, which might be a rewrite or a refactor. So it kind of saps the momentum and ends up with a kind of a messy code base with tiny little patches that no one really understands, and you sort of cross your fingers and maybe write some tests and hope for the best. And you have to kind of take an experimental approach. Team size can be a problem as well. Large teams can be overly controlled, especially in big companies. I've been in a few projects like that where there's a well-defined process. You're not paid to think, you just do. Or you might feel that way, even though it's not true. And small teams are often working too fast, or they think they're working too fast to have time to care about this sort of thing. So another reason we might have dead code is YAGNI, everyone's favourite acronym. I really like that slide. That's the opposite of YAGNI. So if you're driving across the desert, you need to think ahead and bring everything with you. But software is absolutely not like that. You can always just stop and add something if you need it. You don't have to write everything up front. So it's a waste of time, really. Obviously, there are places where this doesn't apply, like a version 1 of a library that you're shipping to a customer or something. But basically, YAGNI is the enemy of, or one of the causes of dead code. It's gold plating and over-specifying. And as I said before, big upfront design can also lead to dead code, because you have to guess 6 months, a year, 5 years ahead of time what you're going to need. So you kind of err on the side of caution and specify too much stuff. So recently at work, I was lucky enough to write a library from scratch, and I was thinking about it for probably 6 months. So I had a Confluence page, lots of ideas. Oh, it's going to need these features. We're going to do this. It's just a sort of a data model, parsing into a data model. And I thought, as you move things around, you're going to need pointers or sort of view UIDs to find objects inside this library. But then I TDD'd it to the best of my ability, which is pretty mediocre. But I went from scratch, and it evolved into something that was quite a lot not like what I thought it would be. It was a bit strange because it kind of grew in this petri dish as a sort of a weird little monster, but it really wasn't. It didn't need a lot of the features I thought it would have done. So I could have started by TDDing those features and it would have worked, but it would have been bigger and more complicated than it was in the end. So that was an interesting lesson to myself about Yagni. And you think you know what you're going to do, but if you can code something from scratch without external interfaces, you can actually end up with something very different. Okay, another reason that I firmly believe leads to dead code is reviewing skill or lack of focus. Again, I'm not criticising anything, but this is something I see quite a bit, which is particularly when you have a reviewing tool that presents a diff, you start concentrating on that diff immediately. It's like, oh, that new variable, is it the right name? You know, the indentation, trivial stuff that's right in front of your eyes. We don't tend to stand back and sort of say, oh, they've removed that line, which was a function call. Does that function still need to exist? You know, was that the last call to that function? So yeah, code reviews don't spot dead code, or they don't spot when a change is causing dead code. So you need to stand back and look at the context. Now, some places are lucky enough to have a senior architect or some form of architectural oversight, somebody whose job it is to know that, and if you're lucky, they'll spot it, and that's great. But I've done this myself many times. You just don't. You focus on what you've been given, and you go, oh, yeah, look at the little things, and that's it. And of course, there's pressure to deliver and move on rather than go back and sort of sit back and look at your old code and go, that could do with some improvement, or I could get rid of that or something. And there's also cultural pressure. Many companies reasonably want you to get on and write new code. Be productive by some definition of productive. Right. Here's your code base. Right. Slight exaggeration. Spot the paint pot. Right. Your job is to work on the paint pot class. There it is. Okay. Once you've seen it, you can spot it straight away. And when you come in the morning and you have to work on paintpot.cpp or paintpot.h, you can go straight to it and work on it and ignore the junk. You can kind of teleport directly into the code and ignore everything else. Whereas in real life, if you had to go and get that paint pot in that room, you're going to have to move a few things around or have very long arms, or, you know, it's code is not the same as the real world. You can ignore mess and focus on areas just by opening a file or closing another file. It's really handy in many ways. But, you know, most people would reasonably want to tidy that room up. You know, if someone said, go and get the paint pot, you'd struggle through and you go and get it and you go, God, that was a mess. You need to tidy that up tomorrow or something. But you don't have to do that with code. So being distracted by the mess is arguably unprofessional, but I can't help it. I suspect many others can't either. Right. So another of the sort of whys is, why has nobody deleted it? And this is the WTF in the code review thing. It's like you look at it and you go, why is that there? And obviously, a lot of people just don't see it. There can be a lot of effort involved in deleting dead code, so the easy way out is not to. Pressure, I mentioned before, you're too busy. It can take time, and you need to be careful about what you're doing, so do something more productive. It's old ground. People are reluctant to go over old ground, or they assume it doesn't exist. They sort of assume that the old code is perfect and all you need to do is write new code. Or often you can't tell it's dead. No one deletes it because they don't see it. They don't know it's dead. It doesn't need to be deleted. I'll cover a lot more on that later. And it's definitely risky. So why take risks? But that risk might be more of a perception than a reality. If it's truly dead code, there's no risk deleting it, other than that you might change the size of a binary, that some function might move to a new address, you might disturb some sort of Heisenberg. But in and of itself, that little piece of code, it's not risky to delete it. But refactoring, removing dead features can be risky. So people avoid that risk. And it feels wrong to delete code, so you just have to get over it, get used to deleting it, and after a while it feels good. I'd certainly say as a junior, you would definitely say, it's not my job, I'm a coder, I'm paid to code. I don't want to delete stuff. Somebody clever person wrote that, why should I delete it?
So there's a common misconception. There's a common misconception that code is valuable in and of itself.
Yeah.
So people hate to destroy value.
Yes.
But they don't realise that code is a cost. It's something that is incurring costs just by being there. It affects the business. And if you reduce your cost, that is also of benefit to the business.
Yes. Yeah, if your code base was 10, print hello, 20 go to 10, there's no maintenance cost. It's just the simplest thing in the world. So yeah, the simplest possible code base to do the job is what you're aiming for. Yeah. I need to speed up a bit. So another thing I've observed is issues around source control, particularly trust. I've seen this in larger companies with older engineers who've had bad experiences, like started out with Visual Source Safe or something horrendous like that. They just treat it as a black hole or as an emergency backup. They don't use it as a tool. They just, they've never used the history or the blame feature to actually work out stuff about their code base. They just use it as a backup, like I said. So the tendency to leave old bits of code in place with comments or hash if zeros around them I think that's where that comes from. Because it's nice to see that old bit of code next to the new bit so that it's all there in one place. But the code is now, the source control is the history. The code should only be now. It shouldn't have the history mixed in with it. It's the same as having those header blocks with the revision control history in the header block. There's a tool for that. Get rid of it. And another thing about leaving fragments of code in place with comments around them is who decides which bits of code are interesting to leave in the code base. Somebody said, oh, I'm just about to move that function, I'll leave the old one commented out. But to somebody else, that's not interesting at all. It's like, it's a very personal thing, and it's enormously distracting. So yeah, source control needs processes around it to help people overcome this kind of friction. And if you're deleting code, I would strongly suggest you have keywords and a sort of a process around that, so that if you suspect code has been deleted, it's quite easy to go into your source control system and find it. So search for a deleted keyword or something like that. Otherwise, you're just adding to the problem that source control is a black hole. Someone deleted some code, I can't find it anymore. So who should delete the dead code? well, obviously you, because nobody else has, because you can see the code, so no one's deleted it. So you're the first person, probably the first person to think about it. It's going to be you. If you're lucky, you might have a technical lead or an analyst who's aware of this stuff and is sort of collating the data as well and just has decided not to do it yet. Hopefully you'll find out about that. But more often than not, it's just you. And if you can't fix it, don't just ignore it. Do something about it, like raising a ticket, putting a to-do or some other keyword comment in the code so that you can go back and find it, or other people can see, oh yeah, someone's aware of that, I agree. But just don't ignore it. So this is the kind of the title of the talk, How to Delete Code. As I said, it's obvious, you just select it and delete it. But it's more about finding it, making sure it's dead, and that kind of thing. The rest of the divisions in these slides are quite arbitrary. There's a lot of points, so I had to gather them together in some form, so that's how I framed it. So sometimes you can just sense the dead code and use your force, sort of magic superpower. But most of the time, it's just you're poking around in the code, doing your day job, and you find something. You go, that looks dead, and that's it. If you're lucky, you can just delete it. Low-hanging fruit. There's a function. I know that's dead. I'll just delete it as part of the piece of work I'm doing. Nice, but it's often not that simple. So obviously you have to investigate the code base. You can't just sort of, if someone says, go and delete all the dead code in this project, it's like you've got to start somewhere. So you have to learn the code. You have to sort of, it's a strange new object, pick it up, handle it, look into it, shine a light into it, do whatever you need to do to sort of understand the architecture so you get a feel for what it is doing and therefore if you see a piece of code doesn't fit with that model of what it's doing in your head, you can say, oh, that's likely to be dead. So there are various sort of non-destructive techniques of finding dead code, and then there are sort of destructive techniques, if you like, which I'll talk about in a minute. So if you look at the structure of your code, if it's well structured, it will be more obvious which bits aren't needed anymore. But typically, certainly the way I've seen it, is the dead code tends to lurk in the kind of blob classes, the big messy spaghetti stuff, because it's hard to see, so it hides there. If it's particularly well structured, it's really obvious when something's not needed, and life's sweet. But lack of structure is definitely a red flag. A small point on coding style is that most projects advocate a particular coding style, and everyone, if they're good, sticks to it. That can hide valuable information. It's if the coding style sort of changes over time, you can look at a piece of code and immediately tell how old it is from the style. And that will then sort of give you a hint that this might be an area of problem or dead. But source control, blame, Git, Subversion, other tools exist. The blame feature, where you can tell the age of every line of code, will tell you that information anyway. But it's nice if you go into a file and go, ooh, look at the style of that. I can tell that was written 10 years ago. I'm going to give it a bit more attention than I otherwise would. I'll talk a bit about profiling later. You can learn about your code base through profiling. It's a bit tricky. Doesn't tell you everything. All right, yeah, that was... So after investigating, the source control history, the most obvious thing is how stale is a file. The assumption is that if it hasn't been touched in ages, it might be dead, but it also might be incredibly stable. You know, core features in your stable core features in your code can live for years without being touched. They just work. The rate of change of a file can tell you a lot. Obviously, if it's changing a lot, there's valuable code in there, but it might also be messy code that needs to be refactored. And similarly, if it doesn't change a lot, it could be hiding dead code. So if you look at the history of a file and look at the most recent changes, so who and why can tell you a lot. Don't get distracted by maintenance type work, like if you go through a code base and change all the headers because you've got a new library or something. That's not really a meaningful change. You need to filter out the housekeeping from the proper code changes. And then you can start saying, well, this file effectively hasn't been changed in a long time or is touched recently. But the main thing is you need to look at the history of a file and understand its history, where it's coming from, what's driving that history. So here are a couple of files with their blames. Hopefully you can see that they're very different. So if you have nice solid color like the right-hand file, it's clearly not changing much. It's either a good solid file or old and dead. The rainbow file on the left, it's clearly a lot of churn. Unlikely to be able to delete things in there, but it could do with a darn good refactoring. So the busy file on the left has 10 years of history and over 400 changes and 13 authors. So that's clearly fairly unstable. So making changes in there would be risky. And the file on the right has 18 years of history, so nearly twice the other one, but only 35 changes. And the last change was 3 years ago. So it's a nice stable file. So you can find dead code through measurement or analysis. There are all sorts of tools for this. Source control, we talked about blame. Most source control systems have a scripting interface. You can easily write scripts to pull out much more useful information. I don't know if people do that. There may be even tools for it. I don't know. It's just a thought. You can profile the code. Unfortunately, that tells you the opposite. It only tell you what code has been executed with certainty. It can't tell you that the code that wasn't executed is dead. All it tells you is that it wasn't executed. So you need the right environment through profiling. And that means don't profile your unit tests, because tests will artificially tell you that code is being used when it isn't. You need to profile the normal use cases. Of course, you can use static analysis. I don't have a lot of experience with the recent tools. Again, you have to make sure you statically analyze the right build. So when you're measuring things, make sure you record the results, not in your logbook or anything, but annotate the source code. Like, I think this function is dead in a comment. Maybe outside of the source code, you want to record some slightly higher level ideas. So document the architecture that you're discovering, particularly if you find there's a whole kind of area of code that seems to sort of be dormant, because then you can talk about that documentation with other people and learn a bit more about it. So some basic techniques for finding dead code. The most obvious is to search. Searching inside the IDE will give you the IDE's view of your code, which is going to be colored by what files it thinks are involved, the build flags, all sorts of other details. So remember to go outside the IDE and just use independent tools. Obviously, grep is the one, because that will just look at all the source code without any blinkers or filters and just tell you a lot more of a truth than the IDE will. Go as high up the source tree as you can. Don't just sort of search in one folder, because obviously other parts of the code might be using this function that you think is dead. Go up to the very top, even if it takes a long time, because it can tell you a lot. If you have a large, complicated build system with lots of different sort of build targets using different parts of the code, you need to look at the whole picture. And if you come up with some interesting grep command lines, record them so you can run them again in the future to make sure that when you have deleted this piece of code you're looking for, make sure it has gone. The easiest way to find out if something is dead is just rename it and let the compiler tell you. Again, that depends on the build that you're building. If you've got multiple builds, it might be hidden by a build flag or something, but it's very easy to do. And the error messages, if it goes wrong, can be really illuminating. It's like, oh, such and such function was calling that and you didn't notice, and now you get a bit of an insight into the architecture. There are many, many other tools. Most IDEs now have plugins. I tend not to use them because they slow things down and fight each other. But I'm sure there are plugins for Visual Studio that will help you find dead code, or at least annotate the source code. There's always the compiler, as I've said, but make sure you're building the right thing. That, you know, the build that you're looking at doesn't conditionally compile out half the source code. Yeah, so lean on your CI system to help you find this stuff. Make changes and see what breaks. And of course, you can test as well. Manual testing is kind of like profiling. If you put a breakpoint in there, if you hit it, obviously that code's being run, but it's not going to tell you what code isn't being run. And if you really need to poke into a dark corner, you could sort of write some kind of special harness. But that has to exercise the code in a realistic way. Otherwise, you can just sort of get into a feedback loop of, oh, my test is running this piece of code, therefore it's not dead. But the test's not the right test. So when you're sort of investigating, obviously take small steps. If you're trying to remove code, go slowly. Don't set out with the target of like, oh, I'm going to remove this entire feature, because it will go wrong. And what tends to happen as you find a dead function is like, oh, well, now the things that's calling are dead, and you sort of, it kind of spreads out through the code or spirals outwards. So you have to tease it out gently. You can't just sort of say, someone's told me that we no longer need this feature, I'm just going to remove it. And subtle dependencies can still remain, so you need to be careful. One technique I've found very useful is moving code around to reduce its scope. You can often find stuff in header files that doesn't need to be there, things that are public, that could be private. Just move things successively to lower and lower, smaller and smaller scopes, and let the compiler tell you whether that's okay. And if it keeps saying, yeah, that's fine, you end up moving things further and further towards the CPP file. And eventually, if you can get code out of a class definition, for example, into a CPP, then you can reason about it because it only exists in that one file rather than in a header that everyone can include. And sometimes that reveals things to you. It's like, oh, this static private function could actually be just a helper function in that class, oh, and no one's actually using it, and you can delete it. Obviously, set boundaries on what you're doing. If you're trying to delete something, don't keep pulling on the thread until it unravels. You can often rapidly get yourself into an unpleasant situation. So back off, stop. Don't just keep bashing your head against a wall and getting the code into a worse and worse state, because no one will thank you for breaking everything. And leave clues, comments in the code, basically. Some thoughts about refactoring. Just because code's been written recently doesn't mean it's special in any way. It might feel like a waste of effort to delete something that somebody wrote a week or a month ago, but the best code is temporary code that appears and then disappears as you sort of move towards a more sort of coherent architecture. So be brave, do that. Something I've done sometimes is to lean on Compiler Explorer. If you can't experiment on the code base because you can't sort of isolate a piece of code, paste it into Compiler Explorer and sort of use that as a kind of test bed and sort of understand the code there. But that's also akin to just sort of pulling the code out into a unit test or a copy of the code. But it's a useful tool sometimes. If you have a complicated refactoring to sort of get yourself to a better architecture where you can remove a load of stuff, move towards it in stages, like with something like expand contract. You don't have to do it all in one go. Obviously, refactor old code. There's a temptation with the kind of TDD cycle is that you're red-green refactor, you're only refactoring what you're writing now, but of course you can go back and refactor old code. That's really what needs to be done. Obviously, refactoring is iterative, but removing code is iterative in that, as I said before, if you remove a function, what did that call? Now the other tendril, sort of the tendrils that spread out, they might also be dead now, so you kind of chase these sort of code paths. It's very hard to be sure that you've removed everything, particularly things like magic numbers and enumerations that certain functions use that are no longer necessary. Those can be very tricky and risky to remove, particularly enumerations, because if you remove an enum, all the other values change. Depending on how your code works, that might definitely be a bad thing. So I've been talking about kind of working in isolation, really, so far. You spot something, fix it. It's often not that simple. If you're lucky, you can start at the top and just do it. Oh, that function's clearly dead. I'll just delete it. But there are a lot of ways of approaching things. You might not be able to do what you want. So depending on your culture, you can come into this list at a level. And if when you start talking about the dead code, you get a lot of blank stares, you probably have to go right to the bottom and start educating people that it is actually a problem. And that's the hardest thing to do, and it's going to take the longest time because you have to start persuading, introduce the concept, talk about it, record what you've got in your code base to say, yes, look, this is a problem. And then start moving up the list until you can actually start deleting things. It's standard kind of project management, people management type stuff. But don't go in like fired up, all guns blazing, say, oh, I'm just going to start deleting stuff, because depending on your project, it could go wrong rapidly. It could just annoy a lot of people. It could even get fired. You know, be careful. Just think about what you're doing, really. But beware that there are techniques. If you say, oh, I just want to delete all this stuff, and everyone goes, what are you talking about? Then, you know, step back and start using some of these techniques. So when you're deleting code, you'll be using source control, I very much hope. Make sure you do it when you're deleting things, you do small steps with atomic commits, because, oh, good grief, am I on 10 minutes already? Lordy.
40 minutes.
I should have believed the timer here that says 51 minutes.
Ignore me.
Make sure when you're deleting things, you do it in terms of source control in atomic commits, so that when it goes wrong, you can revert just the thing you've broken, not as part of a large unrelated change set. Take small steps. It will go wrong, and you don't want the embarrassment of breaking a huge amount of your product. You just want to say, oh, I shouldn't have deleted that. One revert, 5 seconds later, it's sorted. Mike, question? Yeah.
I completely agree with the atomic commits. Have you got any political or career advice if you're in a situation that insists on doing code reviews before you're allowed to do one commit, and you haven't got it on the backlog to delete this thing that's not used? And then I have broken that rule, but it makes it hard to find afterwards. And I don't know how to persuade people who are doing code reviews and Jira and stuff to go, look, let's just do this one thing as 2 steps.
Yeah. Yeah. Your commit message should never have the word "and" in it. So, do this feature, and by the way, delete some code. Because what I just said, you can't then revert the code change without the other thing. You have to start messing around with chunks, and it's really nasty. But if you're forced into that kind of reasonable approach, then you need to, every time you see some new code, some dead code, you just need to put a task in the backlog and take a deep breath and ignore it, which I find extremely hard. But yeah, sort of branch if you can, do another branch for that later. So, yeah, that's all I can say really. It's not nice, but as you're committing your deletions, wait for green build. Don't race ahead, because obviously if you do 10 commits and the build breaks, well, which one was it? And it's much easier to do these small steps. Hopefully your CI is fast enough that it doesn't slow you down. Yeah.
One idea to do this, or mimic this at least, would be to make patches, and then you could later merge them, and then you have every atomic step available later, even if your policy insists on reviewing them before they actually get merged.
Yes.
And that might be a little more tedious, but nevertheless, that would this way you would be able to keep your atomic steps, which is good, in fact.
Yes, yeah. So if you've got a lot of deletions that you're not confident is one change, treat them as unrelated changes and review each one and commit and wait and commit and wait. So yeah. What was I going to say about systematic? Oh yeah, I mentioned it before, but with be systematic in your process with source control around deleting code. Make sure the messages, so the commit messages, are meaningful and searchable. So obviously means sort of choosing some kind of keyword. Okay, so next is what should we delete? Bit vague. There are all sorts of dead things in code bases. I'm really talking about the top two, but there are other things that can be cleaned up.
Dead files.
Yes, yeah. Yes, particularly resource files, icons, images, WAV files that just don't get used anymore. It's hard to spot them because they're not, this is what I said about using your IDE to tell you what's going on. If they're not part of the build anymore, the IDE doesn't know about them, but they're still there. So you need to actually poke around in the file system sometimes. Refactoring dead architecture is probably a whole series of talks. I'm definitely not going there. So, right, the easiest code to delete is properly unreachable code, and your static analysis should find that. Provably unreachable. So you can delete it. Easy. Some IDEs might help you and show it to you. Unit tests will hide it. So you need to have unit test hygiene as well as code hygiene if you're deleting things. But you can also have dead features. So the yellow code there is a dead feature, and it's only kept alive in the code base by the red link. And that could be a single menu item in a GUI or a command line flag, something subtle that someone just says, oh yeah, we don't need that anymore. And you just change one line in a file somewhere, and then all that yellow stuff is unreachable. If you statically analyze the code, there is a path through it. But if the mechanism for getting to that red link is no longer there, it is actually dead. That's quite hard to find. And if you've got a dead feature, particularly if it's customer facing, you might have to be quite careful about how you go about it. Like put an end of life message out, wait 6 months, do it carefully. Don't just go, yeah, that's dead, and then find out that half your customers were relying on it. That would be embarrassing. Yeah, it is, yeah. Sometimes it's like move fast and break things. The only way to find stuff out is to break it. Yeah. So I did some experiments with unreachable code. It's pretty noddy. I hope you can read that. I can't really do much about it if you can't see it. It's on Godbolt if you really want to look at it. I wrote some code and used these tools to analyze it. Now, interestingly, well, to me anyway, the code at line 24, which is a definition without a declaration, none of them found it, but the IDE put a squiggle under it. So something some tool was looking at it. So yeah, various compilers have various levels of help, really. The CPP check is obviously the most useful at this point. But there's a caveat on this in that this is a single file, and I don't think on Compiler Explorer, I don't think there was a link step. The linker can reason a lot more about unreachable code because at link time you go, oh, no one's calling that, I'll remove it. So the results could have been a bit better with a more heavier weight example. But it basically kind of shows you kind of a rule of thumb that some people know about anyway, which is sort of use more than one tool.
Yeah, just for completion or completeness, sorry, I think maybe if you put for GCC in Clang, especially Clang minus W extra, you might get a little bit more.
Yeah. So W extra, okay, yeah. I don't use Clang, so I just sort of, it was a quick experiment. Yeah, another lesson from this is to learn your compiler's flags. W all is the most obvious, but yeah, Clang analyze has all these extra sort of unreleased checkers that can be quite useful. So. But the biggest lesson from this is to make sure you run CPP check in Jenkins or your whatever CI tool, or on your command line, anything. It's doing a lot more than the compilers.
Maybe another remark to compiler flags, CPP check. If you use it with -J, it can't detect unused functions and other translation units. Whereas if you use it plainly, yeah, it can.
Right, okay. It's good to know. Thank you. So another category of code that can be deleted is needless code. Hash includes being one of the worst culprits. I hope you've all seen a large file with 20 or 30 includes at the top. They're almost always not all necessary, but people seem, there's a tendency to add includes when you add a new feature, but never to remove them or clean them up. So include file hygiene is a big deal, really. I don't really know any better way other than just commenting the whole lot out and bringing them back in one at a time until it compiles. Sometimes if one include file includes another one, it's only the sub file, the lower level ones that you need. So different include files would do the job. But basically, every now and then, comment all the includes out and see which ones are truly needed. Obviously, repeated code is needless. Extract clauses into functions, functions into a class or a namespace or a library or something. And if you've got repeated files, fix your source code structure. It's easy for me to say, that's not necessarily an easy thing to do, but if you've got the same file appearing in multiple places that aren't like soft links or something, then something's broken. A lot of code bases I've worked on have their own versions of string classes. It's needless these days. Wrap them in unit tests, replace the guts with STL, and see what breaks. Sometimes that will tell you a lot about why that class is actually needed. You might think, oh, they're just adding functionality that has since become part of the STL, but sometimes there's some little thing that you didn't notice. But yeah, get them into some unit tests, play with them, remove the cool string aspect of it, and use the STL instead. And at a slightly higher level, rather than hand-rolled classes as hand-rolled features, try where you can to replace them with third-party stuff. Again, it's easy for me to say, but 10 or 20 years ago, some of these things didn't really exist in the public domain or weren't usable, and now they are. So challenge, if you've got your own logger class, challenge its need to exist and replace it. There are many, many common anti-patterns that can be deleted or fixed. It's an almost infinite list. One of my favorites is the bool-to-bool converter, which, so I've put it up there. To be fair, this sometimes comes around because of if the code is old enough, it didn't have the built-in type, it'd be an uppercase bool. So you do have to be careful about converting that to a built-in bool. But usually it's just rubbish like this. Obviously the I equals 42 is a Boolean, so you don't need to convert it to a Boolean again. But even this little example here shows how much of a rabbit hole this kind of thing can be, as sort of the arguments about which of those three alternatives is better. I tend to favour getting rid of the else's. When you've got a return at the end of an if, there is no else. Just get rid of it. What comes afterwards is inevitable. There's no third choice for that else. So that's why the better one is the response to that. Better two is much denser because that statement is a bool, but it's pretty meaningless. So better three introduces a bit of self-documentation, even though it's a bit longer. Another one of my favourites is inane comments. That phrase came from Pete Goodliff's Codecraft book. I didn't invent it, but it's a nice pithy phrase. Oh, what? Yeah. So you can halve the code base just by deleting the unnecessary comments, or you get a third of the code base because then you don't need the white space as well. It distracts you. It's like having two people talking to you at the same time. There's the truth, which is the code, and then there's this sort of devil, which is the comments, telling you not what the code's doing, but what the author thought the code was doing, or what the code was doing 10 years ago before someone changed a line but didn't change the comment. So it can be very misleading, and it's very easy to fall into the trap of believing the comments and not looking at the code in isolation. And half of them are just telling you what the language is doing, which you should know. I mean, if you're inexperienced, you wouldn't know it, but go and look it up. You know, you don't explain the language to the audience, just sort of. So, and there's two other points about this. The one comment that should be there isn't, which is far more useful than what the code may or may not be doing, is the fact that it's risky. And it also hides the fact that it should have been SN printf rather than S printf. So it hides a bug. And you think because all those comments are there, the person who wrote it knows what they're doing, and you're not looking for the bug, maybe. Now, there is, in Pete's book, he argues that there's a strong argument for actually leaving that code alone, not fixing the VSN printf bug, but just not removing the comments, because it's a code smell, and if you leave it there, it's a flag to somebody else who comes along. If you just deleted all those comments and left that code, someone would say, oh, such and such has touched that code in the last couple of years. It's obviously current. They've looked at it, it's okay. Whereas if you leave it looking like that, someone can say, that's 20-year-old bad C. It needs fixing. So be careful. I do delete single inane comments, but something like that I'd run away and cry. But what we actually did, which was very satisfying, was we replaced it all with speedy log. But that's because this is logging code. Those options might not exist to you. But comments rot. I favour clean code. So don't be afraid to delete them, particularly if they're just downright wrong. So when is the best time to delete code? Obviously now. Better would have been 10 years ago when you wrote it. but I'm thinking more along the lines of, in terms of project life, day-to-day life cycle, never before a release. It's far too risky. Before a release will mean different things to different projects. If you've got some rapid, every week kind of cycle, there is no avoiding it, but that's fine because presumably you're moving so fast that if you break something, you can easily fix it. But if you, like us, have a 6-monthly release cycle, you want to stabilize the code. You don't want to be doing unnecessarily risky things coming up to the release. But also, if you have a lot of manual testing, you need to think about the impact of that as well. So these kind of thoughts are often what leads to the conclusion that it's too risky to delete any code. Life's hard enough. We just want to test the new code. Don't delete anything unnecessary. Most obvious time to delete the code is when you write it. So just refactor. But it's more likely that when you revisit it, or rather visit it for the first time, because that's when you're likely to spot that something's dead. So basically follow the good camper rules, not Boy Scout anymore, or Girl Scout. It's just good camper. Leave the campsite cleaner than when you arrived. So just do the right thing. Refactor if you can. And if you can't do those, if you can't delete stuff just ad hoc, do it as part of a planned task. So as I said before, record it, put it in your backlog, plan to do it, and then everybody knows you're doing it and hopefully is happy. So that could be just a task on the backlog, or you could collect them together in a kind of technical debt epic or a whole sprint. It's up to you how you run your project. But you might not be able to do it at all, so delete it some other time. As I said, record it, build up a case of evidence that you can actually persuade someone to let you do this at some point in the future. But if you're being prevented, if someone is saying, no, don't do it now, understand the reasons, because they could be quite important. Not the obvious ones like, we've got a release tomorrow, but no, don't go and delete a load of code in that module. We're going to do a lot of work on it next year, or we know about that. It's already slated for deletion. Flag it up and get a conversation going, basically, because you might have missed something. Yes, Roger.
It's also seasonal. My current team, we keep some of the delete dead code and other sorts of refactors of that until the Christmas New Year period, when only a few of the team are in, so there's much less code churn because only a couple of people are actually working on the code base. So that's a great time to do refactoring like that, because you can delete it and there's nothing else changing. And similarly, over the summer, when a lot of people are away on holiday.
Yeah. Yes, excellent advice. So yeah, kind of a planned task, but yeah. Yes, and it's kind of work that typically doesn't need a lot of communication with the rest of the team, so it's ideal for quiet times. I've done exactly that, the 3 days between Christmas and New Year, you just sort of, there's no stand-ups, you just sort of like, I actually are going to do what I want to do, which is to delete a load of stuff. Yeah. So where should we delete new code? I don't mean about physically, but where in the project? Do it in the main branch, trunk, or whatever, so that the history is clear. We use Subversion. I know it's very different with Git. If you do a load of refactoring in a branch and then bring it into trunk, that'll just get represented as one commit. So if your branch is building and the trunk breaks, you've lost that history. And you probably have to have some summary comment, I deleted a load of code. Whereas if you do it in trunk and a load of small commits, the history and the way you were working is clear. If you do it in a branch, particularly if you're kind of doing it as a sort of a side project, there's a chance it might never get integrated and it'll go stale, and then you'll have the kind of merge nightmare, and all that work could go to waste. And particularly if it's a branch that's only on your machine, it won't have CI running on it, so you won't get the benefit of all the tools telling you whether you've broken stuff. So although most people would object, the best place to do it is in trunk, because it's there for everyone to see, and the most of your tooling will be running on it. Delete it everywhere. This is kind of the reverse of doing it in trunk. Make sure you integrate, that you merge those changes into all your branches, so you haven't got people working on old code that might actually tell you that that code shouldn't have been deleted. And also, if you then merge it into someone's branch and that breaks, that immediately tells you something, which is that you shouldn't have deleted it. You might be able to fix the branch, but more likely you need to revert it and propagate that change. Wherever you do it, make sure all your tests are running on it. You have, bring all your CI to bear on it to analyze it as best you can to prove that you were right in deleting it. All right, I've got to the end. So some conclusions. People and projects and even companies have bad habits. Challenge them. Or if you don't feel that you can, at least challenge yourself and break your own, but either break your own bad habits or form habits that subtly challenge the rest of the culture that you're in. You've got to change something. But the worst habit is not thinking. It's just sort of like, yeah, it's dead code, whatever. Measure everything, or measure as much as you can. If you need to build up a case, you need evidence. Record everything that you find so that the time you did spend understanding it isn't lost. And talk about it. Often the discussion is what throws the light into the dark corners that you're looking into, and you find out, oh yeah, no, that's there because of this, or yeah, we thought about deleting that, but it caused this problem. If you start talking about these things, other people's point of views will come to play, and you will learn something. And if there is no kind of pushback, they will learn something, in that you found this dead code, it shouldn't be there. Everyone's happy. This whole talk really is a plea to refactor. If you're not used to it, start small and build up. Just get used to doing it regularly. But basically, you need to find what is dead and what can be safely and responsibly deleted. Some things are best left alone, but do what you can. Yeah, so just be brave and start deleting some code. It can be addictive, and once you start, you can't stop. One contract, I was at a place for a year, and I didn't measure it, but I'm absolutely convinced that I deleted far more code than I wrote, because I just found this corner that it was a total nightmare, and I just started deleting stuff, and this messy architecture collapsed in on itself, and more deleted, and in the end, there was this simple little piece of code. unfortunately, I've been guilty of this myself. The person that wrote it had swallowed the patterns book and over-engineered this thing. It was heavily sort of, it was full of unnecessary architecture. But yeah, it can be fun. It's very satisfying. Some obligatory image credits, just in case. There are 4 particularly relevant books. However, since writing this talk, there have been a number of excellent talks here at ACCU this year. So if you're watching this on a video, go and look at, there's at least 2, I think, about large architectures, and there was yesterday's brilliant keynote from Laura Savino about coping with other people's code, which is quite a good complement to this. I've gone into some detail and she was talking about it in very general terms, but a lot of that resonated with me when I was in there. I was thinking, oh God, she's taken my talk. But yeah, basically just press the delete key more often. Right, and with that, questions?